Question 1. A company wants to deploy a new web application that requires automatic scaling based on CPU demand and needs to maintain high availability during OS updates without downtime. They also need more control over individual VM instances within the scale set, including potentially using mixed VM sizes. Which Azure Virtual Machine Scale Set orchestration mode would best meet these requirements? Option A, Uniform Orchestration. Option B, Flexible Orchestration. Option C, Manual Orchestration. Option D, Hybrid Orchestration. The correct answer is Flexible Orchestration. Here's the explanation. Flexible Orchestration mode offers more control over individual instances, allows for mixed VM sizes, and is suitable for stateful workloads or those requiring specific instance naming. It also supports rolling updates and integrates with autoscaling for high availability. Question 2. A DevOps team is deploying an application on an Azure Virtual Machine scale set and wants to ensure that the application running inside the VMs is healthy before new instances are added to the load balancer or unhealthy instances are replaced. Which feature or extension should they implement to achieve this granular health monitoring? Option A, Azure Monitor CPU Metrics. Option B, Azure Load Balancer Health Probes. Option C, Application Health Extension. Option D, Custom Script Extension. The correct answer is Application Health Extension. Here's the explanation. The Application Health Extension is crucial for enabling health-based autoscaling and instance replacement by reporting the application's health times inside times the VM, allowing VMSS to automatically replace unhealthy instances to maintain availability. Azure Load Balancer Health Probes only check if the VM is responding to network requests, not necessarily if the application itself is healthy. Question 3. Which of the following statements accurately describes a key difference between Azure Virtual Machine scale sets and individual virtual machines regarding management and scalability? Option A, individual VMs inherently provide auto-scaling capabilities, while VMSS requires manual configuration for scaling. Option B, VMSS simplifies management by treating a group of identical VMs as a single logical unit, offering built-in auto-scaling and load balancing. Option C, individual VMs are ideal for stateless applications, whereas VMSS is primarily designed for stateful workloads requiring unique configurations. Option D, VMSS allows for easier deployment and management of disparate VM types and operating systems within the same set, unlike individual VMs. The correct answer is VMSS simplifies management by treating a group of identical VMs as a single logical unit, offering built-in auto-scaling and load balancing. Here's the explanation. VMSS simplifies the deployment, configuration, and management of large numbers of VMs as a single logical unit, providing inherent high availability, scalability, auto-scaling, and integration with load balancing. Individual VMs require manual scaling and separate management. Question 4. A developer wants to deploy a web application to Azure and needs a fully managed environment that abstracts away server management, OS patching, and infrastructure provisioning. Which Azure service is best suited for this requirement? Option A, Azure Virtual Machines, IaaS. Option B, Azure Kubernetes Service, AKS. Option C, Azure App Service, PaaS. Option D, Azure Functions, Serverless. The correct answer is Azure App Service, PaaS. Here's the explanation. Azure App Service is a platform as a service, PaaS, offering specifically designed for hosting web applications, abstracting away the underlying infrastructure management, OS patching, and server provisioning, allowing developers to focus on code. VMs, IaaS, require full infrastructure management, AKS requires cluster management, and functions, serverless, are for event-driven, short-lived tasks, not general web applications. Question 5. Which of the following statements correctly describes the relationship between an Azure App Service Plan and an Azure App Service application? Option A. An app service application can only run on a dedicated app service plan. Option B. An app service plan defines the underlying compute resources, VMs, pricing tier, scaling, while an app service application runs on that plan, and one plan can host multiple apps. Option C. An app service plan is a logical grouping of app service applications without defining compute resources. Option D. An app service application is a separate billing entity from its associated app service plan. The correct answer is, an app service plan defines the underlying compute resources, VMs, pricing tier, scaling, while an app service application runs on that plan, and one plan can host multiple apps. Here's the explanation. The app service plan is the fundamental compute resource that defines the region, OS, size, scale, and pricing tier. An app service application runs times within times an app service plan, and multiple applications can share the same plan, leveraging its allocated compute resources for cost efficiency. Option A is incorrect, as multiple apps can share a plan. Option C is incomplete, as the plan defines compute resources. Option D is incorrect, as the plan defines the billing for the compute resources the app uses. Question 6. A company needs to deploy updates to its production web application with zero downtime and the ability to test the new version thoroughly before making it live. Which Azure App Service feature is explicitly designed for this scenario? Option A. Auto-scaling. Option B. Virtual network integration. Option C. Deployment slots. Option D. Managed identities. The correct answer is deployment slots. Here's the explanation. Deployment slots allow you to deploy different versions of your application to separate staging environments, test them, and then swap them into production with zero downtime. This is ideal for seamless updates and A/B testing. Auto-scaling is for performance, VNet integration for network access, and managed identities for secure authentication to other Azure services. Question 7. What is the key characteristic of Azure Container Instances, ACI, that differentiates it from Azure Kubernetes Service, AKS, for running Docker containers? Option A. ACI provides a full-fledged container orchestration platform for complex microservices. Option B. ACI requires you to provision and manage underlying virtual machines for container hosts. Option C. ACI is a serverless solution that runs containers directly without managing underlying VMs or orchestration infrastructure. Option D. ACI is primarily designed for long-running, stateful applications that require persistent storage by default. The correct answer is ACI is a serverless solution that runs containers directly without managing underlying VMs or orchestration infrastructure. Here's the explanation. ACI's core strength is its serverless nature, allowing direct container execution without the need to provision or manage VMs or complex orchestrators. AKS is for orchestration. A. ACI abstracts VMs. B. And ACI containers are ephemeral by default. D. Question 8. A developer needs to run a short-lived, burstable task that processes uploaded files. The task should only incur costs when it's actively running and should start quickly. Which billing model and feature of ACI are most beneficial for this scenario? Option A. Monthly flat-rate billing and dedicated VM instances. Option B. Per-second billing for allocated CPU and memory, and fast startup times. Option C. Pay-per-container instance, fixed daily rate, and manual scaling. Option D. Annual subscription cost with unlimited resource usage. The correct answer is per-second billing for allocated CPU and memory, and fast startup times. Here's the explanation. ACI offers per-second billing for allocated CPU and memory, making it cost-effective for intermittent or short-lived tasks. Its fast startup times, containers running in seconds, are ideal for burstable workloads. The other options describe different, less suitable, or incorrect billing/provisioning models. Question 9. While Azure Container Instances, ACI, are ephemeral by default, which method allows you to provide persistent storage for data generated or used by your ACI containers? Option A. Directly attaching an Azure managed disk to the container group. Option B. Mounting an Azure file share to the container group. Option C. Utilizing Azure Blob Storage for in-container data persistence. Option D. Configuring an internal database within the ACI container group. The correct answer is mounting an Azure file share to the container group. Here's the explanation. ACI allows you to mount Azure file shares to provide persistent storage for your data, ensuring data is retained even if the container stops or restarts. Managed disks are for VMs. Blob storage is object storage, not directly mounted as a file system for persistence within the container in this context. And an internal database would still lose data if the container is ephemeral without external persistence. Thanks for watching. Please subscribe to my channel.